Welcome, and thank you for joining this session. I'm Taylor Carpenter with Vulk Co-op. I'm going to give an introduction to CNCF's telecom initiatives on behalf of the Cloud Native Computing Foundation and Dan Kohn, its VP of Strategic Programs and the General Manager of LF Public Health. Currently, there's 3 telecommunication-focused initiatives within CNCF, including the Telecom User Group, the CNF Testbed, and the CNF Conformance initiative. They all share the goals of helping telecom operators and developers in navigating the cloud-native and open-source landscape to obtain the benefits touted by cloud-native technologies. The Telecom User Group is a place for operators, vendors, and telecom developers who are using or aim to use cloud-native technologies to share their ideas, experiences, ask questions, and voice their concerns and needs. It's not expected that software development will occur within the Telecom User Group, but it may write up documents covering requirements, best practices, and tips that it's learned. The Telecom User Group started as birds of a feather meetings in Barcelona and Shanghai during 2019, and has since moved to once-a-month Zoom calls and online conversations in Slack and emails. The Testbed initiative is an open source platform, toolchain, and set of examples that supports reviewing the different emerging cloud-native technologies within the telecom domain, supporting reproducing its test results and use cases, as well as building new prototypes and reference examples. The third and newest initiative is CNF Conformance. It's an open source test suite that supports validating cloud-native network functions, or CNFs, as well as telecom platforms' adherence to cloud-native principles. It helps to provide test results for the CNFs and the telecom platforms which it tests to operators to help them identify solutions which are observing cloud-native capabilities and principles which are important to those telecom operators themselves. It also hopes to help CNF developers in demonstrating conformance to cloud-native best practices and provide tools and feedback for those developers to improve their technology. There's public telecom-focused meetings, including the Telecom User Group's monthly meeting, which occurs at 1500 and 1100 UTC, alternating monthly, with the next call on Monday, August 3rd at 1500 UTC. There's also a weekly meeting on Thursdays for the CNF Conformance and Testbed, which is a technical meeting occurring at 1400 UTC. In addition to those meetings, there's also a mailing list for the Telecom User Group, public CNCF Slack channels, and you can reach me directly via email at taylor@vulkcoop or Dan Kohn via dan@linuxfoundation.org. CNCF is collaborating with other communities, including the Linux Foundation Networking and all of its initiatives and projects, the Cloud Infrastructure Telco Task Force, CNTT, as well as the new Platform as a Service initiative, XGVela, which China Mobile is a part of, in addition to CNCF's own special interest groups and projects. We'd love to have your feedback. We've created a survey. We'll show this again at the end. A little bit more about the Telecom User Group. There's currently quite a few members, including vendors and operators like Nokia, Swisscom, T-Mobile, Huawei, China Mobile, as well as direct collaboration with other groups like CNTT, OVP. We're currently working to share requirements with CNTT RAs2, the Kubernetes reference work, as well as the reference implementation, where things are shared from the CNF Testbed on tooling. And we're also providing a cloud-native checkbox for the CNTT's RC2 program. Regarding documentation and papers, there's been a white paper, The Cloud-Native Thinking for Telecommunication, created. It's in the Telecom User Group's GitHub. And there's contribution and references to the Cloud-Native Networking Principles papers. This leads us to something important that's being discussed. What is cloud native and what does it mean for telecom? Well, cloud native builds on existing principles and practices like DevOps processes, service-based architecture, and agile software development, which may be familiar to many operators and telecom developers. CNCF outlines some of these things in their cloud native definitions, including microservices, immutable infrastructure, declarative APIs. These allow high-impact changes frequently, predictably. You can do things like moving security patches safely to production. And the Cloud-Native Networking Principles papers go in more depth on all of these principles and provide extensive references and allow you to ask questions and answer them, such as how are cloud-native systems loosely coupled? How do you provision immutable infrastructure? And how do you configure these cloud-native systems? As well as what are the underlying properties and principles? This leads us to what is a cloud-native networking function? Well, a cloud-native network function is a cloud-native application which implements network functionality. We expect it to then follow cloud-native principles like using microservices, having immutable infrastructure, having declarative APIs and configuration, using a repeatable deployment process. Likewise, a telecom platform that is itself cloud-native should follow these principles, providing service discovery, declarative configuration, and resiliency for the workload and platform itself. The CNF Testbed, which has contributors like Cisco, Intel, Samsung, Nokia, the FDIO project from LFN, contributes to this open source initiative, which helps us review cloud-native technology. You can think of the CNF Testbed as an innovation review tool. It helps review this software by supporting different technology options, keeps things as simple as reasonably possible so that you can understand the different components, and used upstream community tooling like CubeSpray and NFE Bench so that you can become familiar and we can provide bug fixes and things we've learned to those upstream projects. And of course, it tries to follow cloud-native principles as much as possible. This goes all the way from hardware up through all the levels. So we try to focus on immutable hardware, providing configuration that's saved in version control, even for the underlay network. Bootstrapping is repeatable from the hardware all the way up through the workload. And then we try to highlight gaps that are missing and out-of-band procedures that have had to be used. And then we try to find technology that can solve those out-of-band procedures. And we highlight any technology that meets cloud-native principles. It's fully repeatable in packet from hardware all the way up through the workload. It uses Helm and kubectl for use cases, CubeSpray, the Kubernetes project, and we try to use Kubernetes native replacements as much as possible. Examples go from very minimal, simple things that you can try to see how technology is used all the way through service chaining and use cases. Some of the technologies that are demonstrated include network service mesh, different CNIs, different topology and NUMA CPU managers. You can replicate this using the published code in the CNF Testbed with an API key from Packet. And if you package your own network function in containers, you should be able to run it in the testbed. We'd be happy to accept pull requests for improvements in the tool chain to add support for your own lab, other cloud providers, as well as new use cases and examples. The CNF Conformance contributors include different vendors and operators. This open source test suite is showing and focused on how well CNFs and platforms follow cloud native principles. It's based on the Kubernetes Conformance program, which is not only open source, but focuses on self-validation. So anyone can download and use this suite with your own CNFs and platforms. We've organized the test into categories, which we find helpful for discussion, including configuration lifecycle, upgradability, scalability, and resilience. The different cloud native principles and capabilities are the tests that are covered that are within these categories. These categories cover both platform and workload tests. When we take a look at the workload tests, the first set that we've covered are part of these categories, including microservice, security, like privilege mode, configuration, looking at liveliness and readiness check, upgradability, as well as resilience, where we look at stuff like chaos testing, where we expect the workloads to continue to function if one of the nodes goes out or a pod. On the platform conformance side, we're focused on Kubernetes-based platforms, and we expect the test to reference CNTT, Kubernetes reference requirements, direct feedback from operators and CNF developers, as well as the Kubernetes community best practice and cloud native principles themselves. Some of those potential tests, in addition to Kubernetes conformance, include horizontal auto-scaling capabilities, including hardware itself, where more nodes could be added as needed, more resilience testing, including intentional failures in nodes, and verifying that if traffic in the signaling either fails or is under high load, that the data plane workload will continue to function as expected. We also want to test not only the core platform, but any type of add-ons for metrics, whether they're standardized Kubernetes add-ons, and whether or not they have network policies that are following the Kubernetes network policies so that you can use them together with all of the other configuration. We've included some CNF examples like Core DNS, Envoy, a VPP-based IP forwarder. Linkerd is in progress. We have other examples that could be included in the future. And when we get to using the CNF Conformance Suite, we have an extensive set of instructions and usage guide, from a minimal set for a CNF developer to quickly get started, through extensive source-based installation and usage for running individual tests or groups. We've outlined prereqs. We've shown how you can test using your own Kubernetes cluster, or how to deploy clusters that we use with our tool chain. We've also included instructions for configuring and using CNFs with example configuration files, which you can copy and follow directly. This is an example of how a test run would work for a CNF itself. If you ran all the tests, you should see the individual tests with pass or fail, and then a final score will be shown, and all these results will go into a log file. The scoring system itself consists of a summation of all the individual scores for the final score, which can be weighted for positive or negative based on the importance. and modified in an external YAML file. The test results themselves are saved in the YAML configuration files, the summary as well as all of the information for individual tests. If you'd like to get involved, we have a contributing guide. We have the installation and usage guide, which I mentioned before. We'd be happy to receive pull requests for documentation, adding new CNFs, or tests for both the platform and the workload. If you can attend the upcoming meetings, there's a Telecom User Group on August 3rd, the weekly CNF Testbed and Conformance technical meetings, August 6th at 14:15. We'll also be speaking at Coop EU on August 19th, as well as ONES North America on September 29th. You can join us in the mailing list for the Telecom User Group on the CNCF's public Slack channels. You can email me or Dan Kohn directly. If you'd like to speak with Dan Kohn, he's offered to speak. You can reach out to him on his Calendly. We'd love to have your feedback on how well this introduction to telecom initiatives helped you. If you'd like to sign up for beta testing for CNF Conformance and provide other feedback on how CNCF can help you as a CNF, as a telecom operator or CNF developer. Thank you.